looking at the unit circle. So when we look at trig ratios, most of us already know, well, let's presume that we understand that when we're talking about, say, the sine ratio, we look at the angle, the reference angle, and we take the opposite side and divide it by the hypotenuse. Okay, so that's sine of whatever angle our reference angle is. Sine of theta is the opposite divided by the hypotenuse. So when we talk about a unit circle, we like to use this because it kind of simplifies our sine and cos ratios a lot. So the unit circle is really just a circle that's drawn on a set of axes, so the x and y axes, and the length of the hypotenuse is exactly 1 unit, and the length of the hypotenuse is also the radius of our circle. So from the center of our circle, we can draw a line out exactly 1 unit to anywhere out on the edge of this, and it will make a circle. So as this 1 unit arm spins around this circle, I create a circle by putting points. Okay, but the size of my hypotenuse is exactly 1 unit. Okay, so when I'm looking at my ratios, if I've drawn a line out, as you can see in this diagram, and I've put a point on the end of that hypotenuse, which is also on the outside of my circle, on the circumference of my circle. So I've got this circle that's radius 1, and I'm looking at this particular point here. The location of that point is how far I've come along the x-axis, and it is the same as how far I've come along the y. So my location of my point is x, y. If I then start to think, okay, well, this is my point on a graph. So remember, we're looking at something that's on a graph. So that point there, the location of it is whatever the x coordinate is and whatever the y coordinate is. If I now start to think, well, from this point, I'm going to drop this line down that has already been drawn in, and I'm going to draw a line across along my x-axis, I actually create a right angle triangle. And the angle inside there is the angle made by my hypotenuse. So I've actually got myself a right angle triangle. I've got a reference angle in that left-hand vertex of the angle we're going to call theta. So I've got this point xy. The height of my point above the x-axis is y, and it is also the same as that side length of that triangle. And the distance out along the x-axis of where my x coordinate is also the length of the side of the bottom of that right angle triangle. Okay, so this point xy doesn't just tell me a point on the circle, it actually tells me the length of one side and the other side of my right angle triangle. So if we're thinking about our trig ratios, y is going to actually be our opposite side. Theta being our reference angle, y is the side that's opposite the reference angle. X is going to be our adjacent side because it's right next to the reference angle that we're looking at. So in my unit circle that we're looking at right here, if I'm talking about sine of my angle theta, in this particular instance, only in the unit circle, the size of sine theta is going to be y, because that's the length of my opposite side, divided by the length of the hypotenuse, which we already know is 1 unit. Okay, so let's just label that so we can see what we're doing. Okay, so I've taken my y value here, because that's the opposite side to where my angle theta is, and I've put that over 1. And of course, anything divided by 1 is just the number itself. Okay, so in this case, sine theta in my unit circle is going to be y. By the same token, cos of theta, which is adjacent divided by hypotenuse, is going to be x over the hypotenuse, which is 1. So cos of theta is just going to be whatever the length of x is. And tan of theta, which is opposite over adjacent, is going to be y divided by x, because they're the lengths of my two opposite and adjacent sides. So that is the first quadrant of the unit circle.